Welcome to this new webinar. Today, we will explain how the beta tester program works. For sure, you are all already students from the free course and already registered here in this free FEM course. So, to join the beta tester contest is very easy. As you already have seen in the website here in the free FEM course. On the occasion of the upcoming release of CivilFEM 2021 version, we have some new improvements, and we would like you to test them. You may be already a CivilFEM user, so most of you already know how to perform a full analysis in CivilFEM from the geometry definition, materials, cross sections, meshing, load application, and so on. Or if you are new users, you have here in the free FEM course tutorials, okay? And we always recommend you to use the forum. And here you have instructions for the software installation, which is very easy. This CivilFEM 2021 version has a limit of for this student version has a limit of 50,000 nodes, so it's enough for you to perform all the models. And yes, if we open the here in the free FEM course in the beta tester section, you have all these bases. The winner of this contest will receive a free training grant of any of and a 2 months expert license with technical support included for any type of project that he wants to carry out. And of course, all participants will receive a certificate of participation and an additional discount in any course of this International Center an education center in any CEA course. So once you are registered, you will get the software. As it is explained here, you have these resources, and we will want you to perform an analysis. We recommend you to use any of the new developments. Later I will show you which are the new, mainly the most important developments. We told them as well in the release webinar. Okay, and we will between all these models, there will a winner will be selected. Okay, the duration of this program will be 1 month. I don't know, maybe probably it can be extended, but we will see. Okay. Yes. You have many workshops. If you already performed them then you can try the new developments, which are here in the free FEM course. In this part, you can see here that we have the new stress and strain diagram for concrete design, and along with the developments, you have some recommendations, some examples to so you can follow them, and it will give you an idea, well, a good idea if you carry out the examples of these developments. Okay, the concrete user design, stress and strain diagram. Now I will explain some of these examples. The new thermal structural couple analysis. Okay, you can combine both the structural and thermal strains and get structural results, and include always material temperature dependent properties. In this case, we will show you transient thermal analysis on a steel beam. The beam will be we set a fire on a beam, and we'll see results. Some other geometry improvements, as the new geometry importation from the IFC, from the beam modeling. The congruent mesh is very useful as well. Before, we had to always create shared topology, shared geometry in order to get a conforming mesh, but now the software will detect automatically all the components, all the entities which share common lines, common points, or common areas, and the mesh will be performed with coincident nodes. You won't need to do any merging. Okay. There are new mesh tools for the parasolid option of meshing, the activation of springs, integration of forces and moments of solid sections. We had a 3D option, and now we have the 2D for 2D. Okay, well, for the fiber reinforced concrete design, this is a particular case of the new development of the design of the new stress and strain diagrams for design. We have an exercise which was shown in the webinar. This hyperbolic paraboloid. We will give you the geometry of these paraboloids, and you will have to define two new diagrams. One for the design stress and strain diagram in order to perform a code checking after the structural analysis. We will add two types of diagrams. One which with low dose of fibers. Okay, you just need to insert values for the 28-day diagram. You have here the values and the different values for strains as well, and this is the chart. And another one for the high dose. Okay, you have them here. And then using this data, well, it doesn't say here the units, but it's 4 centimeters. Okay, sorry, 40 centimeters. These are the materials: mechanical cover, And the loads are just self-weight and vertical surface load, which will be the snow, and this will be the load case. This is very easy. Okay, the boundary condition just will be to constrain the bottom nodes. Later, you will perform a code check of the structure. You can include rebar mount if you want, or you can perform a design to get the reinforcement. Okay. And in case you are performing a code check, you will have this type of results for the criterion. Okay. So yes, if you check you will have more information if you check the webinar of last of the release, the last webinar. Here it is explained that we already had the analysis stress and strain diagrams for crack to analyze cracks in cracking and crushing. But now here, if you go about the minute 3, and then here it is explained as well, which is the process of this calculation. Okay, you will have, yes, here, you know, if you have here, you will have just the model, okay, the geometry, and you can continue with the definition of the, check here, here it is. I'm going to open it here. You have this, just the geometry. You will have to create the materials with the different design diagrams, and the rest of perform the mesh and the loading, solve, and then perform, after structural analysis, perform the code check or the code design. Okay. Well, another another new development is the definition. Well, here we can import new type of geometries, which is the IFC, along with the other types which are already available, the XF and Parasolid and STEP. And now the industry foundation class is very typical in B models is defined, and well, any type of structure of geometry will be imported. Of course, you will have to debug and clean a little bit the geometry that is not needed for, as they are not taking into account in the structural analysis. Okay. Yes, about the mesh, you have now, if you already know how to mesh in CivilFEM, we have this geometry, which is not shared. We have this slab and walls, roof, beams, lines. We have, if we create the structural elements, we have the option here in 2020 version or below, the typical mesh option. But now, if we click on Congruent Mesh, it will auto-detect the common entities. Okay, so if we, in this case, we just mesh as a standard way, and here you can check that the wall and foundation do not have coincident nodes and here for beam, the beams and the roof as well, they, as you can see, they are not going, they don't have coincident nodes. If I check here, if I see that the nodes of the shell and the nodes of the beam are different. But if we use the new option, the new mesh congruent option, you can check in the example, which is available in the free FEM course, the beta tester program. You can see here how the new mesh is performed without adding local mesh parameters. And even if the edge size are different, the mesh in the common parts will be conforming. Okay, you can see here, and must be here as well. Okay. Yes, about the thermal couple analysis, there's a new example which was uploaded just today. It's very interesting. It's just an I-beam, IP300 beam, and with two type of loads, just structural pressure and thermal load. So here we are talking about a heat transfer analysis, and it will be a 3D and transient because we will set a load, a thermal load, which will be depending on time. Here, as it will be solid, we can create the beam using creating point by points, the geometry of the IP300. But well, I will do it here. Okay, I'm going to perform the first part of the definition for you. Okay, I will import the geometry. And it's the DXF is as well provided. Here we have the lines, and we just need to create a new surface. Just select all of them, the 16 lines. Here I have my profile section. I just need, I want to, as I have my surface, I will need an extrusion. So I define my axis. It's a 10-meter line, and I will use it as an extrusion. My I-beam. Here I have it. Okay. I'm going to hide Here is my volume. I just need to mesh. I will define the material and my mesh. I will use the extrude surface mesh. I will set 5 millimeters edge size for the transverse section, and I will use 25 centimeters for the extrusion. Okay, depending on your resources, it will take more or less time. But here, after the definition of the geometry and mesh, you will start with the definition of the material properties. Okay, it's a step-by-step exercise, so it will be easy for you, but it will include new capabilities, very interesting capabilities about how to set a fire condition. Okay, let me check. Here we have it. Here we have our new. There's a new capability as well, which is the edge thickness, which now it's available here, and you can modify the edge of the element, the finite elements. Okay, so for viewing, it's very useful. Okay, so that's it. From here, you can continue the example until you have here the boundary, thermal boundary conditions, and here is the thermal law. Okay, this is the temperature and the time. So a table must be defined. Here it is. We have a structural load, which is the pressure, a thermal condition, the solution controls, and then, as it's a nonlinear analysis, the time might differ from you depending on your mesh and your properties. If you follow the slides more or less, you will have a total analysis of 82 minutes until the yielding of the beam. Okay, and you will have structural results and thermal results. You can check for all the, here you have them as well. I have it solved. You will have here the different results for each time, and you can plot them. Okay. The most critical parts will be the studied ones will be supports and middle span. Okay. And you will have the option as well to plot history results along time, along the total analysis. You will have the variation of the strain here, or stress and strain results as well. Here you have them, which are very interesting. Okay. And if you want to animate the results, here you have the equivalent plastic strain, the temperatures. This is the view of the support and the view of middle span. This is the von Mises stresses. And we will set a fire, and you will have results until the non-convergence because of the collapse of the structure due to plastic yielding. Okay, so that's it. It's you have all the tools to start this beta tester program. Please always use the forums. You have here total support from us. And good luck. Thank you very much.